Hi guys, so today we are solving this problem called sliding window maximum. Let's read it. You are given an array of integer nums. There is a sliding window of size k, which is moving from very left of the array to the very right. You can only see the k number in the window each time the sliding window moves right by one position. Return the max sliding window, right? So we've been given this array and we have been given a size of k window, and that window we need to find what is the maximum value or value from the that window, and we need to return that and put it in an array and keep on sliding that window of size k and return the maximum possible value in that size k window and add it in the final array and return that as the answer, right? So for example, for the first one we have 1 1 3 minus 1, right? So 1 3 minus 1, what is the maximum value? 3. So 3 is considered. Then we move the window by one step, and k is actually 3 for the first example, right? So we move it by one step and we consider the next three elements, which is 3 minus 1 minus 3. So the maximum possible value is 3 here, and we use that. Then the next one we have minus 1 3 minus 1 minus 1 minus 3 5, which means the maximum possible value is 5, and we consider that. And similarly, we move one step ahead again, minus 3, 5, 3. So maximum possible value is 5. We consider that. And then we have 5, 3, 6. Maximum possible value is 6. We consider that. And 3, 6, 7. Maximum possible value is 7. And we consider that. So the approach that we'll be using is of maxi, which is basically a priority queue we'll be using of max heap, right? And we'll be putting elements one by one and checking if the top element, which is the maximum size element at the top, is it within the range of the window that we've been considering, right? So that is the idea. So let's simulate it for the first example. 1 3 minus 1 minus 3 5 3 6 7, right? So first example is that. So the first window is this one. And in my priority queue, what I'll be doing is I'll keep on adding elements. So first I'll add 1, comma 0. So I'll add the value as well as the index to keep a check on the window size, right? So if it's the index is within the window. So we put that, and then we have 3. So 3, comma 1. Then we have minus 1, comma 2, right? So this is how it will look in the priority queue. The maximum value is 3, right? And 3 will always be at the top of the priority queue, and we'll be using that. So right now, the window is actually like one window is complete, right? So what is the maximum possible value on that? 3 is the maximum possible value. So we add it in the array. Then we move one step ahead, right? So when we move here, we add minus 3. So minus 3, comma 3. So that is at the bottom. But still, the maximum possible value is 3, right? And 3 is within the range, right? So within the range of, the next particular three elements, right? So 1, 2, 3, right? So 3 is still within the range. Then we move to the next one. We have 5, right? So 5 comes at the top because that's the maximum possible value, right? So now we have 5. So 5 is, we pop that out and we put it in the final array. And 5 is within the range, obviously. Then we move to the next one. We have 3. So 3 again comes down and add it here. And still 5 is the max possible value. So 5 again for the next range. Then we have 3, 6, 7. 5, 3, 6, right? So that range. So we have 6. So we add 6 at the top, and 6 is the greatest, so we consider the 6 as the next element. Then we move to the next range, 3 6 7, right? So max possible value is 7, and 7 is at the top. So we consider that and pop that out and consider it in the final answer. So that is our output. So right now we have already considered the array, which is having all these elements, right? And we are considering everything which is at the top of the priority queue, and we use that, right? And that will be our final answer. So just to make sure that, nothing at the top of the priority queue is without, like it's not within the range, right? We'll pop that out, everything which is at the top of the priority queue, which is not within the range. So this will be a sanity check every time we are pushing a final answer into into our final array, right? So we'll just check if it's within the range of I minus k. If it's less, sorry, not within the range, but less than equal to the I minus k. So for example, I have I'm at the seventh index, right? So because the range is only of size, the k window size is only of 3, so k is 3. So 7 minus 3, right? We have 4, right? So anything which is equal to 4 and below, if that is at the top of the priority queue, I'll remove that. So that will be a sanity check that I'll do before putting elements into the array, right? A final array, basically. So yeah, that is the idea. Let's get to the coding part in order to understand this approach a bit better. Right. Let's get to the coding part. So first of all, I'll have a pair of int, comma int, and that will be my priority queue. And then I'll have an answer array. And then I'll just iterate through the nums. And here I'll do my sanity check, which is if PQ is not empty, right? And then PQ dot top dot second, if is less than equal to I minus K, if that's the possible value. So second, at the second, I'll always store the index, right? So if that index is less than equal to I minus K, I just pop it out from the ITQ. And then I just push the element of nums of I and I, right? And then I put it in the answer array. So answer dot push back the PQ dot top dot second, whatever is at the top of the second. Before also like the first window only completes when it hits the index of k minus 1, right? So if I is greater than equal to k minus 1, right? If that is the possible value, like if it's above the first range, right? Then only we start pushing in the answer array, right? And then in the end, I just return the answer. Let's run it to see if everything is working fine. Just wait, I minus k, right? So here we are pushing the first, not second, right? Cool. That's submitted. I hope you guys understood the problem. Thank you so much.